You're listening to a production of the National Media Archive. To learn more or volunteer, go to nationalmediaarchive.com. Amazon now has over 1 million robots moving around inside its warehouses. To put that into perspective, this number is almost equal to the total number of people still working in those same warehouses. And while the robots keep multiplying, the people are heading in the other direction. So far this year, Amazon has laid off 35,000 people. That is enough people to fill a small city. The real story here is not just about robots rolling around with boxes. Amazon has built a new artificial intelligence system called DeepFleet. This system is not about moving faster in the sense of robots speeding up. Instead, it works by planning smarter routes and using every second more efficiently. Think of it like a giant brain watching every aisle and telling each robot when to turn left, when to pause, and when to zip around another machine. The result is about 10% less travel time for each robot. That might sound small, but spread that tiny gain across 1 million robots and you get huge savings in time, money, and energy. If Amazon's plan keeps working, we might see this idea spread everywhere. Picture the entire shipping industry running as if it were one giant thinking machine. Every truck, ship, and warehouse could someday act like a single living organism that never sleeps. It would be able to adjust itself in real time, avoiding traffic jams, moving goods faster than humans could ever plan, and squeezing out every bit of wasted time. This is the big question people are asking right now. If Amazon has 1 million robots already, what happens when shipping companies, delivery services, and local stores all copy this idea? At what point do human workers stop being necessary for the basic jobs that keep packages moving from point A to point B? Some people say we should not worry because people will shift into higher-level roles. Others see warning signs of entire parts of the economy being automated away without a clear plan for what comes next. Meanwhile, another company is quietly hinting at a different kind of artificial intelligence future, one that feels like science fiction stepping into our living rooms. The company that runs DeepMind, which is known for pushing the limits of artificial intelligence, has been showing off its video generation model called VO3. This system can create realistic video scenes complete with sounds, dialogue, and detailed backgrounds. What makes this interesting is not just that it can make videos that look like movies. People have started wondering if this tool could be turned into something you can actually play. Right now, VO3 works more like a movie camera that films a scene exactly as you ask it. But what if it could do more? What if the video could react to your actions like a video game or a training simulator? For that to happen, VO3 would have to stop being passive. A passive system only makes a fixed video from start to finish. An active system would have to think on the fly, adjusting every piece of the world based on what a person does inside it. That would mean mixing video generation with what we already have in game engines, which are the tools that power modern video games and make sure characters, objects, and physics all respond in real time. If someone finds a way to merge these two ideas, we might get something completely new, a world where entire scenes are generated in real time, with characters who can talk back to you, worlds that bend and change, and experiences that blur the line between watching and living inside a story. It would not just change entertainment. It could change how people train for dangerous jobs, prepare for complex tasks, or simply spend their free time exploring digital places that feel almost real. Behind all this talk of robots in warehouses and movie engines that might become playable lies an even bigger conversation. There is growing chatter about what a national push for artificial intelligence might look like if a country really treated it like the moon landing or the atomic bomb project that changed the world back in the 1940s. One research group laid out exactly what a modern artificial intelligence mega project could look like if the United States decided to go all in. Their idea is to gather every big piece of computer power into one place, run by one central agency, and push development forward at a speed that private companies cannot match alone. They say this kind of project could eat up about 0.4 to 0.8% of the entire United States economy every year. That might not sound like much, but we are talking about spending $100 billion to $240 billion each year. To make that happen, they would need new power plants, giant buildings packed with servers, and a supply chain ready to crank out more and more advanced computer chips. Security would be a constant concern. If the country builds this much computing power, it will need to guard against spies, sabotage, and any risk of artificial intelligence being used for the wrong reasons. Some say the plan should be wide open so the public knows what is happening. Others believe parts should stay secret, like a modern arms project. If this idea sounds far-fetched, think again. As the race between countries heats up, leaders are waking up to the fact that building artificial intelligence capacity is no longer a choice. It is becoming a matter of staying competitive on the global stage. If one country figures out how to build smarter, faster, and more capable systems first, it could tilt the balance of economic power, defense power, and even what kind of inventions show up in everyday life. That is the landscape right now. On one side, robots are slowly matching and maybe even replacing humans for physical labor in warehouses. On another, artificial intelligence tools are creeping closer to making entire virtual worlds you can step into and interact with as if they were real. And behind it all, people are asking if countries should treat this wave of technology as the next big national mission. As we keep watching these stories unfold, the tools people are building today give us small clues about where things might be heading. One of the tools making waves this week is called Cursor version 1.2. This is an artificial intelligence agent planner that helps break down big tasks into smaller steps. Instead of doing one thing at a time, it can figure out what should happen next, in what order, and how to juggle tasks so that the whole process moves faster. Think of it like a really smart project manager living inside your computer. People who work in software development or any kind of technical field are starting to use these kinds of agents to write code, check for mistakes, and plan how different pieces of a project fit together. When tools like this get faster and better at understanding context, meaning all the tiny details that surround a task, they can help people move from idea to finished work with fewer delays. Another interesting tool is VO3, the same video generator we talked about earlier. The newest version has just been released around the world, which means more people will get a chance to see how good it is at creating lifelike videos from a few typed prompts. While it still does not allow you to move inside its scenes or control characters in real time, the technology is improving fast enough that some people believe it will not stay passive forever. Next up is something called TreeQuest, which comes from a company experimenting with how artificial intelligence agents can work together like a team of collaborators. Instead of one giant artificial intelligence doing everything, TreeQuest lets smaller artificial intelligence agents specialize in different parts of a big problem. When a tough question comes up, the agents split the work, check each other's progress, and find answers faster than one agent working alone could do. This approach could be useful for problems that do not have simple yes or no solutions. For example, planning the best route for hundreds of delivery trucks across multiple cities, or figuring out the best way to match medical data with new treatments. When the problem is too big for one brain, having a team of smaller digital brains working together could save time and money. On the coding side, a project called Deep Software Engineer, sometimes called DeepSWE, is now available for anyone to use. This tool is like having a top-level software engineer ready to help at any time of day. It can write large chunks of computer code, test that code, and even explain how everything works in plain language so a human developer can check or adjust it. Open sourcing Deep Software Engineer means people everywhere can study how it works, improve it, and use it as a building block for their own projects. For companies without big software teams, tools like this make it easier to build apps or run experiments that used to require hiring expensive engineers or outsourcing to big firms. A quick look at some other developments this week shows that the artificial intelligence world never really sleeps. One well-known figure in the research space has taken over as head of a new company focused on what they call safe superintelligence. The idea behind safe superintelligence is to make sure that when artificial intelligence becomes extremely powerful, it does not cause unexpected harm or drift away from human goals. At the same time, the company Together Artificial Intelligence has shared its deep software engineer project with everyone, and another group called Higgsfield dropped a tool named Soul in Paint, which lets people edit images and animations with high detail. This means you could change parts of a picture or a video scene without having to redraw or reshoot everything from scratch. One of the coding platforms, Replit, has also rolled out something called Dynamic Intelligence. This tool is designed to give artificial intelligence agents more independence. Instead of waiting for humans to tell them every small step, these agents can plan ahead, check their own work, and push projects forward with less human babysitting. And over in the world of large models, people are watching closely for the next version of Grok, which is rumored to come with a new games feature. This could hint at more interactive artificial intelligence experiences that blend conversation and entertainment in new ways. Not to be left out, ByteDance, the company better known for its social media apps, has launched a tool called XUniMotion. This one focuses on creating image animations so realistic that the movement looks like it came from a real camera rather than computer graphics. Artists, designers, and video makers are already wondering how this will change the way they bring characters and scenes to life without huge teams or expensive equipment. When you add all these stories together, you can see a bigger pattern. We are not just talking about a handful of new gadgets. We are seeing the outlines of a world where every piece of creative work, physical labor, planning, and problem solving has some layer of artificial intelligence working behind the scenes. The robots in the warehouse might seem far removed from the tools artists use to edit video frames, but they share a common thread. They all rely on large amounts of data, smart planning, and the ability to adjust to tiny details in real time. It is not just about replacing jobs, though that fear is real for many. It is also about stretching what is possible. People can plan faster, create faster, and even dream up new jobs that never existed before. But each step deeper into this world of automated agents and synthetic minds also raises new questions. What happens if millions of people lose work faster than new kinds of jobs appear? Who owns the output of these artificial brains? How do we keep them safe from misuse? And what does it mean for everyday life when so many tasks become invisible, handled by systems that few people fully understand? In this moment, the tension between promise and risk is shaping how leaders, businesses, and even regular people talk about artificial intelligence. Some believe that we are heading for a golden age of productivity and creativity. Others worry that it could widen gaps between people who control this technology and people who do not. Picture a small business owner today. They might use one or two artificial intelligence tools to write emails faster or generate ads. But in just a few years, that same business might run on a fully automated backbone, robots or smart agents handling accounting, customer service, supply orders, shipping, and even legal paperwork. For bigger companies, these layers of automation are becoming more like organs inside a living creature. Each artificial intelligence part has a role. One handles planning, another checks for mistakes, another learns from data, and improves the system day after day. Together, they can react faster than any human team could hope to. This is where that idea of the supply chain as software really starts to make sense. In the past, supply chains were huge webs of factories, trucks, boats, and workers. People ran the show, and delays often came down to miscommunication, bad weather, or human error. Now, companies like Amazon are testing what happens when software, not just spreadsheets, but live artificial brains, takes over the flow of real things. When the plan works, packages reach doorsteps sooner, costs drop, and companies can promise same-day or even same-hour delivery in more places. The flip side is that every gain in speed and precision pushes human workers further to the edges. They become supervisors, troubleshooters, or managers for the robots, but fewer hands are needed on the warehouse floor. This is not just happening in shipping. Think about movie production. In the old days, big studios needed huge crews, expensive cameras, and weeks of reshoots to make a single scene look right. Now, tools like VO3 can generate realistic video with believable sounds and details, all from a handful of typed directions. While these systems are not fully interactive yet, the day when someone can step inside an artificial world and control what happens next is coming closer. Imagine a training program for firefighters that uses this kind of technology. Instead of running through expensive physical drills, trainees could enter a simulated burning building that reacts to their every move. Or a factory worker could practice repairing machines inside a virtual plant that mirrors the real one, learning what to do before ever touching real equipment. Some people even see these virtual worlds blending with daily life. Meetings could take place in spaces that look and feel almost real, where colleagues walk around digital tables instead of staring at flat video calls. Entertainment could become an endless playground of scenes that reshape themselves each time you jump in, driven by artificial intelligence agents that react to every decision. Meanwhile, those calling for a national push to build out artificial intelligence capacity say that if one country does not do it, another will. In this view, not building a giant artificial intelligence backbone means falling behind on everything from economic growth to defense planning. But this kind of push raises its own problems. Where do the billions come from? Who controls the computing power? How do we guard against accidents or misuse, especially when artificial intelligence systems can write code, analyze security gaps, or even generate convincing fake videos in seconds? Many believe we will need new rules, better oversight, and maybe new kinds of insurance to cover damage if something goes wrong. Others argue that innovation should not slow down because of fear, pointing to past leaps like the internet or nuclear energy where risk and reward were locked together from day one. So as this week closes, the news about 1 million warehouse robots, video models that might someday become games, and national artificial intelligence blueprints all feed into the same bigger question. How far should we go to build smart systems that think and work alongside us? The coming months and years will test how ready companies and governments really are to balance profit, safety, and fairness. For many, the best case is a future where humans do less of the boring, repetitive stuff and more of the big, creative thinking. But that vision only works if people have a clear place in this new machine-driven world and a real say in how it grows. Right now, the choices being made in warehouses, research labs, and government offices are drawing that future one system, one job, and one robot at a time. Where it all leads depends on how we decide to share the benefits, spread the risks, and keep our eyes open as we step into a world that is learning to run itself.